Hi, everyone. So this is the end of the second part of So Odd I Can't Even. We're on page 201. Well, this is technically not on page 201 because this is our do now. And given these two functions right here, let me be purple today. So x to the fourth plus 5. And one way you can and remember end behavior is what is the graph doing at the end, right? How does it behave at the end? And I'm talking about at the very beginning or very when it's very negative and very positive. Okay, so if you're looking at these at the x-axis, we're looking at all the way over here on the left hand side and all the way here on the right hand side, the positive infinity. And so what I like to do is in my brain, I'm like, okay, well, let's put in a negative infinity. What do I get? A negative infinity to the fourth power, right? If we could really do that, we can't. So, but I mean, if we could, is what? Is negative times negative times negative times negative. There's 4 negatives, which means those two are positive and those two are positive, right? So which means we end up with a positive number. So that's why we know as x approaches negative infinity, f of x is going to approach positive infinity. The reason why I say f of x here is because this is f of x. If this was like y, then I would write this as y. It just pertains to whatever this function is, whatever function we're talking about. All right, now we talked about the negative side. Now we're going to talk about the positive side. So as x approaches positive infinity, what is y doing? Well, let's plug in positive infinity. Positive infinity to the fourth power. Well, if we have 4 positives, what do we get? Still positive, right? It's not going to be negative. So that's why we just put in positive in here. So it's going to approach positive infinity, it meaning f of x. All right. Notice this plus 5 is of no consequence. It could be plus a million. It doesn't matter because infinity is much bigger than that, right? So all we're looking for is we look at the x with the biggest exponent. That's the thing that's going to affect it the most. All right. I think this also might help you. Well, what if instead of saying f of x is equal to, what if I said it was negative 2x to the fourth plus 5? How does that change it, right? So let's try that out. So as x approaches negative infinity, because I like to start with negative first, and then f of x, oh, maybe I should not write f. I'll say g of x. So g of x approaches, do you see how it changes? Right, what does g of x approach? So let me see. So if x is some big negative number, so g of some negative number, right, is equal to negative 2 times some negative number to the fourth power plus 5, right? So negative to the fourth power. Remember, there's 4 negatives, which means they cancel out, right? 2 negatives make a positive, 2 negatives, when we multiply them, make a positive. So this is a positive. So it's going to be negative 2 times some positive number, right? Whatever that is, right? Plus 5. So what's the negative times a big positive number? It's still going to be negative, right? Because of this negative 2. So this one is going to actually be negative. It approaches negative infinity. Do you see how that makes a difference? And this plus 5, again, if this is a huge number, even if you add 5, that's not going to make it all of a sudden positive. It's going to still be negative, right? If you're like the United States is like trillions of dollars in debt, right? If you pay them $5, do they all of a sudden not become in debt? No, they're still in debt. It doesn't matter, right? If you like owe like a $5,000 in taxes, okay, 5,000, that's still a lot. And then you like pay them $5. Are you all of a sudden not in debt? No, you still are. Okay. Sad days. Hopefully you're never in that situation. But that's what this is. So when we're talking about very extremely large numbers, these little numbers are not going to matter. So that's why we just look at this part right here. Okay. And then let's try this again. So as x approaches positive infinity, what is g of x going to do? So what if this is a big positive number? So I'm going to write this down here. So negative 2 to some big positive number to the fourth power. Positive to the fourth power is still positive, but that resulting, we need to multiply that by negative 2. That makes that negative as well. Okay, does that make sense? It's getting better. Okay, this stuff is very abstract, so it's kind of sometimes difficult to understand. So you're gonna have to give your brain a chance and let it process a little bit. Okay, sometimes you just need to let it mull over inside your brain for just a bit. Okay, and then so here we have this graph right here. One thing I did in class was remember, where does negative infinity live? On the x-axis to the left. Where does positive infinity live? On the right. Where does negative infinity live on the y-axis? On the bottom, like way on the bottom, and then positive infinity up there. All right. So as x approaches negative infinity, so as we go to the left, where's this graph going? It's going up, right? Do you see how it's pointing up where infinity lives or positive infinity lives? Yep, and that's why it's going up. And then if we go to the right, so as x approaches positive infinity, so as it goes more and more to the right, where's the graph going? It's going down, right? It's literally pointing down. So it's going to where negative infinity lives. Okay, it doesn't actually live there, but you know, well, it does, but there's no living going on. It's just infinite. It's a concept, right? So that y approaches negative infinity. Why did I put in y? Because there was no mention of f of x here. There was no name for this function, so I just called it y, right? If there was a name for it, so if I put on here, oh, this is p of x, then you would write here p of x. If it was like p of t, then you write p of t. But then this should be t as well then, right? T is whatever that is on the x-axis. Okay, go back from there. All right, so that is our end behavior. Now today we're going to be talking about symmetry in a variety of forms, and we're going to be talking about odd and even functions. So notice right here, it says the line of symmetry when it is the y-axis. That tells you if the function is even, right? So if you have your book, the right book, volume 1, this is what I would highlight, all right? And then another thing, and we do a little synopsis of it. So if it is also, if it is has rotational symmetry, right? So if it has rotational symmetry, so when the central point is the origin, i.e. 0, 0, then that's how we know that the function is odd. Now note, just because it has an odd degree does not make that an odd function. Weird, I know. And so it's right here. This is the synopsis here. And just because it is x to the 4th power does not make that automatically an even function. What makes it an even or odd function is this definition right here. So an even function has a graph symmetric about the y-axis, reflectional symmetry. An odd function has a graph symmetric about the origin. It has to be at the x-axis of the, not x, it has to be the y-axis here. It has to be that, because they may have it may be symmetrical, just not across the y-axis, right? If it's not across the y-axis, not an even function, all right? And this one has to be the origin. Again, it may have a center of rotation and it may have reflectional symmetry, but it may not be, the center of rotation may not be at the origin. It has to be at the origin for us to consider it to be odd enough, all right? And so, yeah, make sure you highlight this as well. This is exactly what I was talking about. So odd and even functions are not the same as odd and even degree functions, okay? So please read that a couple of times just to make sure you know that. All right. So again, this is like a visual of it, right? So if the line of symmetry is the y-axis, then it's even. This is the even function. If the center of rotation is the origin, then it's odd. And if none of these hold, right? If none of these hold true, then it's neither. So basically, if it doesn't, it's not the first one, it's not the second criteria, then it's just neither, right? Because that's the only other possibility. All right, so let's practice. State whether this is even or odd. So this is what we said. Note right here, it is reflected across the y-axis, exactly the left as the right, and the right is exact same across the y-axis. So therefore, even. And for B, if you look right there, if we have, first of all, you know that the one arm is up and one arm is down, which means it's definitely not going to be even. So we're going to check for if it's odd, right? Because one arm one up and one arm down is always odd. Well, it's always an odd degree function, right? Not necessarily that's odd. But if we take that, see that dot right there? Take this dot and we're going to like literally just flip the graph upside down, like on your book. In your book, if you have your book, flip it upside down. Does it look exactly the same? You'd be like, no, it's not, right? So that's how we know that it's going to be neither, because we know it's definitely not even, so we don't even need to check that. You can if you want to. But the left, does the left look like the right? No, one arm is down, one arm is up. But this one right here does not have rotational symmetry across the about the origin, so neither. And this one right here, notice right here, yep. Flip it around. Yep. Right. Notice it intersects right here at 0, 0. That's a thing. Okay. So that would be odd. How odd. Okay. And we were again talking about end behavior. If you think about this, okay, so we know that this is an odd degree, right? If it's an odd degree, that means one arm is up and one arm is down. So the only thing we need to worry about is, well, if the x is really negative, right? If we put a negative in for this this x right here, that's to the third degree, which means that it's going to be still negative. And then we're multiplying that by 2, which does not change that negativity. So then that's still going to be negative right here. Okay, so 2, some big negative number to the third power, that's going to make it negative, times a positive is still going to be some negative number. Some negative number. Okay, and that's what makes this negative. And if we're going to put in a positive, right, the positive x, if this is positive in here, so 2, some positive number here, so positive number here to the third power. Positive to the third power is going to still be positive. We multiply it by another positive number, which is this 2, still going to be positive. This is going to be some positive number, right? So we know it's going to approach positive infinity. It's going to be going up. Okay, so on the left-hand side, it's going to be going down, is down, then up, and down. It's going to look something like this. I don't know what that middle part is doing. Is it doing one of those curves? I don't know, right? But right now what I'm worried about is these arms right here. What is the left arm doing and what is the right arm doing? This x approaches negative infinity, that's the left arm. X approaches positive infinity, that's the right arm. Okay, if you want to think about it like that. All right, and then if we're going on, right here, this is g of x is equal to 6x squared plus 10. What is that going to look like? So it's x squared, which we know, ooh, that's quadratic, which means it's parabola. Is it open up or open down? Like, oh, well, A's got to be open up. A's positive, so it's open up. So we know that it automatically looks like this. And so in your brain, you're like, okay, that means everything goes to positive, because remember, that's where positive lives on the y, right? So as x approaches positive infinity, g of x approaches positive infinity. As x approaches negative infinity, g of x also still approaches positive infinity. Either way we go, left or right, still going to go up, right? Because it's open up. Okay, same thing with this one right here. And so somebody was saying in class that A was positive, right? Because there's no number there. So it's positive. So this is what that's going to look like. If you don't remember that, you could always just logically reason it out. So if x is some really big negative number, negative to the third power is still negative. So h of x is going to approach negative infinity. And if x is some big positive number, it's going to be that positive number to the third power is still positive, so therefore positive. Okay, so I would honestly just try these out. Oh, are these going to be even, odd? What are they? So let me just X out on these ones. So we have here, so remember 2x to the third power. What is it? Minus 3x. And if you notice right here, so a lot of things going on in the middle there, but ultimately the arm goes down, which is what we said, right? And so the more right we go, where's that right arm going? It's going up. And just like what we said. And then the second one is going to be 6x squared plus 10. Right, and notice, yep, opens up. So as x goes more and more to the left, what is y doing? It's going up, which is positive infinity. So both of them are positive infinity because they both go up. That's where positive infinity lives, on the y. And then right here, this other guy, a little bit more complicated guy. So x to the third minus 3x squared minus 2x plus 7. Ooh, there we go. Notice the arm still, left one is down, right one is up. Left one, x approaches negative infinity, going down. So that's why it goes to negative infinity. And as we on the right arm, that one, it goes up. So that's why it's approaching positive infinity. Right? Hopefully that's helpful for you guys. And oh, we should have talked about even and odds. Let's do that really quick. So is this an even function? Okay, definitely it's odd. At least it could be odd or neither. It can't be even for sure because first of all, it's an odd exponent, right? So, and that means one arm is down, one arm is up. It's never going to be like if you go look in the mirror and you raise your arm like this, and in the mirror, the person raises their other arm, you need to run. Like that's a weird mirror. You need to run away fast, right? Yeah, that's not okay. Okay, so definitely it's not going to be a reflectional symmetry. So we're looking, is it rotational? And if you were to flip up this video upside down, if you can, unless you have auto rotate, in which case you can't do that. You'll have to flip yourself upside down. This is not rotational symmetry. Notice that it does not cross the origin, which is a good indicator whether it's going to be rotational symmetry or not. So, and then let's take a look at the other one. This one, what is this? Okay, both arms are up, which means, okay, we're not looking at an odd function, right? We're not doing for rotational. It's not going to work, but we can see if it's reflectional. So does it have a line of symmetry right here on the y-axis? Yes, it does. So yes, this one totally does. If I added in here, like instead of doing that, I put in like +2. Now does it have it? You're like, well, it's still it's literally just shifted, right? You're not wrong. But is the y-axis the line of symmetry? You're like, well, no, that's definitely not right. So you will just say, yeah, no, this is neither. It is not symmetrical across the y-axis. Yeah, and it doesn't have rotational symmetry across about the origin. That's what you would say. All right, let's try this one. Ooh, flip it upside down. Yeah, so it totally has rotational symmetry. So this is an odd function. Not strange, it's just odd. Not weird, it's just odd. All right, and we had talked about these in class. Remember looking at these graphs, I'll just X this out. So x squared, yeah, this is definitely going to be an even function because the y-axis is the line of symmetry. And if we add in here the x minus 3 to the square, and notice it just shifted, same shape, shifted to the right, but now it is no longer an even function, right? Because the line of symmetry, it still has a line of symmetry, it's just not the y-axis. So therefore, it is not an even function. It is neither. And then the last one right here is going to be 3x squared. There we go. And notice it's a little bit skinnier, right? A little bit skinnier than this guy right here. Not by much, but still a little bit skinnier. It got pulled, right? But it still does have the y-axis as a line of symmetry, so we're good. So this one is definitely still going to be an even function. Right. Hopefully that helped you. If not, let me know. Bye.